most popular model answer for this question uses the exact method that the examiner says rarely leads to full marks. Two methods you could choose: substitution or elimination. Both are needed. Substitution I would only use when I can't use elimination, so that would be for quadratics and possibly for some linear equations. In this case, elimination just lends itself here. If we choose the y variable here and we multiply equation 1 by 3, we get 5x minus 6y equals 46, 69. Let's just check that. 23 times 3, 9, 6. I chose 3 because then I get 6 here. And if I multiply this one, number 2, by 2, I get 6 as well. So 2 times 2x is 4x. 2 times 3y is minus 6y, so this is 36. I want you here to spot my deliberate mistake. What have I done? I think you might be able to see here I have not multiplied the 5x by 3. So 5x times 3 is 15x. Now I end up with two equations where I can eliminate one of the variables. So here I can get rid of the y by taking them away. Let's do that. So 15x take away 4x gives me 11x, and I end up with minus 6y minus 6y, which would become minus 6y plus 6y, which would equal 0. So I end up with 0 there. And then 69 take away 36, and I would end up with 33. So I get 11x equals 33, and I get x equals 3. So just to recap, I've decided I'm going to use elimination. That's the first thing. The other bit to do is to choose which variable to get rid of. Now again, I've chosen the y variable to eliminate, but I could have chosen the x variable, but it's a little bit more complicated, as there'd be more minuses to deal with. So I could have multiplied 1 by 2 and 2 by 5 and still got the same answer. I've got x equals 3, so now I have to finish this off. And to do that, I need to work out what y equals. I would lose a mark if I didn't work out what y equals. So I'm going to do that. I'm going to take this 3 and substitute it back into one of these original equations here. Let's take equation 1, why not? So I'd get 5 times 3 minus 2y equals 23. So that would imply that 15 minus 2y equals 23. I'm going to take this 2y onto this side. So I'd get 15 equals 23 plus 2y. Yep, so I add 2y to both sides. I'm then going to take away 23 from both sides. So I end up with 15 take away 23. And that would equal 2y. If I take away 23 from this side, I get 0, remember? So I'd end up with minus 8, because 15, if I take away 23, I'm going to go past the 0. 15, I'm going to go past the 0, and I'm going to get to minus 8. So I get minus 8 equals 2y, and that implies that minus 8 divided by 2 equals y. So y would equal minus 4. So I've got two answers here, 3 and minus 4. I'm not quite finished though. I need to double check. I'm in this GCSE exam. Who's going to tell me that I'm right? I haven't got a teacher to tell me that I'm right. I haven't got a textbook to tell me that I'm right. I haven't got Google. I haven't got any sort of artificial intelligence. All I've got here is myself. So I need to double check this. And I'm going to do that by substituting these two values here back into these two equations. So let's start again with 1. So we've got 5 times 3 minus 2 times minus 4. And hopefully that should equal 23. Let's see. We get 15. And we have minus 2 times minus 4, which makes plus 8. And that does equal 23. So first check, correct. But I need to do the second check, because remember, the point of these equations is that I have two values, x and y, that satisfy both equations. So then I would do 2 times 3 again, minus 3 times minus 4, and hopefully that should equal 18. Let's see, 6, and then we have minus 3 times minus 4, which is plus 12, and that does equal 18. And so my correct answers are x equals 3 and y equals minus 4. So just to recap, we've got method choice, elimination, not substitution. And although substitution might look clean in some textbooks, under exam pressure, it's where students slip. So this was confirmed in the, as I say, June 2024 paper. The second bit, choose your variable, eliminate the y first, multiply to get 6y, because eliminating x leads to bigger numbers and more subtraction errors with negatives. The other bit here, check by substituting back, and that's what we did here. We plugged in our values into both the originals. And if you'd made a mistake here, for example, and got a positive 4, or you'd made another mistake with a negative somewhere, that would be caught, I should say, in the checking bit. And the other bit, just to say here, that was pointed out, be clear with your working. You can see here, I have clearly gone down the page, first of all. Okay, I had to go across here a little bit with the checking, but my main working is going down the page. I've underlined my two answers. I've also used numbers to label these equations here. And I've done all my workings out here on the right, including my checking. If you want to practice this type of question with an AI tutor that gives you hints instead of just showing you the answer, there's a link in the description.